everyone. So this is the last part for the 2.1 Bohr's atomic model, part 3, limitations of the Bohr's atomic model. So this is a person, okay, who involved, okay, for this part. Okay, you already know the Niels Bohr, okay, from the beginning of the 2.1, and right now, okay, I will introduce you with the Louis de Broglie and Heisenberg. Okay, limitations of the Bohr's atomic model. First, it is unable to explain the line spectrum of atoms or ions containing more than one electron, such as helium. We know that helium has 2 electrons, so Bohr cannot explain, okay, for the atom that has more than 1 electron. That's why from the beginning you can see that I only give you the example for the hydrogen atom, because Bohr only can explain for the species with the 1 electron only. Okay, and then the next one, electron is restricted to move in a certain distance around the nucleus of an atom. So Bohr said that electron, when it moving around the nucleus, okay, at the fixed diameter, alright, so electron is said that it is restricted to move in a certain distance around the nucleus of an atom. And the third one, it unable to explain the extra lines form. Okay, this one same as the first point. Okay, so it cannot explain the extra lines, okay, form. And then it unable to explain the dual nature of electron. The dual nature we refer to the wave-like properties and particle-like properties. That is the dual nature of electrons. So this is the limitations of the Bohr's atomic model. Okay, let's see de Broglie's postulate. Okay, de Broglie not agree with the Bohr, because it said that the tiny particles like electrons can also have the wave properties. Electrons should diffuse like wave into dimensionless space, and electrons should not be confined to a particular energy level. So this is the formula for the de Broglie's postulate. Wave properties, okay, it includes the wave properties equal to the h, Planck constant, and m, it refer to the particle mass. Okay, it said that it has the this is the particle lights. Okay, and u is for the velocity, meter per second. So this is a diagram, okay, to differentiate between the Bohr atomic model and de Broglie. So for the Bohr atomic model, it said that the electron, okay, moving around the nucleus at the fixed distance. Alright, but de Broglie postulate said that the electron has dual nature, wave-like properties and particle-like properties. So the electron, this is how it shows that the electron has the wave-like properties. It moving around the nucleus in the wave form. Heisenberg Uncertainty Principle. Heisenberg Uncertainty Principle said that it is impossible to know simultaneously both of the momentum and the positions of moving particle with the certainty. So you cannot determine at the same time momentum and the positions of the moving particle. An electron should not be confined in a particular orbit because its exact positions and velocity cannot be determined. And you can only determine the probability of finding an electron, which is by using this formula. Delta x, we refer to the uncertainty in measuring in positions or uncertainty positions, Delta P we refer to the uncertainty in measuring momentum, and larger than Planck constant over 4 pi. Okay, so this is a formula for the Heisenberg Uncertainty Principle. You don't have to use this formula for the calculations. Okay, you only have to explain what is the Heisenberg Uncertainty Principle, including this one, and you have to state what is the delta S, delta P, H, and 4 pi. Okay, so let's see the analogy. Okay, pretend you are running down the sidewalk as fast as you can go. One friend is going to see how fast you are going, and another friend is going to tell you exactly where you are. Is this possible? No, it's not possible to know both of the exact speed and location at the same time. In order to know exactly where you are, you will have to stop. However, if you stop, then you can't measure how fast you are running, because at this moment you are not actually running. So this is an analogy which you cannot determine the momentum and position at the same time. If you know the speed, then you wouldn't know the exact locations. If you know the exact locations, you wouldn't know the speed, because when you are not moving, so there is no speed.